responsiveness.
So it steps you through that process.
I'm panicking already.
Call for help.
That's the next step
Help.
you do.
Start CPR.
So now we're going to dive into medical device applications and the components in them with Paul Arrico of Analog Devices here at Wilmington, Massachusetts. Paul, welcome.
Thanks, Brian. Welcome to you, too.
So these are very cool devices, and none cooler, at least in terms of a naming convention, than the Wheezometer.
Correct.
Walk us through that.
Sure, you bet. So this Wheezometer is a device that's actually used for people that suffer from asthma. So I think for many years now, people that did suffer from asthma had really no way of determining kind of the level of medication that they needed to take. There was really no way to measure that. So the Wheezometer is actually a really nifty little device that essentially measures the acoustic properties as you breathe in and you breathe out. Over 30 seconds, 50 seconds, 60 seconds, it records the actual profile of the sound, breathing in and breathing out. And it actually then runs through a series of algorithms on our Blackfin processor. It's a fixed point processor. And it actually puts out a result that determines the wheeze level of that person, which helps in kind of the medication process.
Next up, the Fall Saver.
Yeah, the Fall Saver is really, this is a very unique device also. And this is really, it's a small company that developed this product, and what you're seeing here is this is a base station. This is really targeted more for clinical hospital applications. But what it really does is it reduces the falls. It's based on some of our MEMS accelerometers. This is a device that actually sits in a Band-Aid. You can't, this is the PCB, it's a battery, there's a transmitter in here, an RF transmitter, but it sits in a Band-Aid, and you literally apply it to the back of your thigh.
Okay.
So if I'm sitting down, if I'm a person in the hospital sitting down, and I stand up, this device actually detects that I stand up.
Right.
It wirelessly transmits to a base station that could be at the nurse's call center, and it identifies that this person is standing up that shouldn't have been standing up. So it's really a very simple, elegant solution to some of the falls that are occurring in hospitals that cost insurance companies literally billions of dollars a year. So this device here is called a pocket CPR, and it was developed to assist people in performing CPR and performing CPR correctly. So I'm going to turn it on. It's fairly loud, but it's
Okay.
really kind of shows you exactly how it operates. So it's really a training tool. This is really what it is. It's a training tool, but I'll step you through it.
Stay calm. Check responsiveness.
So it steps you through that process.
I'm panicking already.
Call for help.
That's the next step
Help.
you do.
Start CPR.
So now when I start CPR, I place this on the person's chest, and now when I'm compressing the chest correctly, all 4 lights will light up. And basically you want
it's
Good
sensing.
compression.
it senses the exact compression depth. When I'm compressing correctly, that 1.5 to 2 inches, those 4 LEDs stay on, as you saw there. If I'm not doing that correctly, it's only 1 LED. So it steps me through the whole process of performing CPR. So that's the
Nice.
pocket CPR.
Nice application.
Okay, thank you. And the final device we have here is really, again, this is kind of a breakthrough solution. This is by a company called Cygnostikoi, and they've developed literally it's a handheld ultrasound platform. And what's a little unique here is that this is using Analog Devices gyro technology. It can actually detect the probe as I move it, swing it back and forth, and back and forth.
I see, yeah.
It's determining the location of the probe relative to this point here. And by moving this here and the gyro kind of determining the location of the probe, it can recreate the signal here. So instead of using a fairly expensive, power-hungry transducers in the probe, they can use much lower cost, fewer transducers to actually capture the image. In addition, this is using power management products. It's using high-speed analog to digital converters because the transducer itself operates at a very high frequency. The whole goal here is really to be able to take some of the technology that's been located in the clinical settings and get it into the home. So what I'm showing here is products that can really offer diagnostic value.
Right, right. Well, very cool. Thanks, Paul.
Okay, great.